we've seen costs drop by like a factor of 10,000. This is impossible to do on Ethereum, really impossible to do even on layer 2s. It's going to cost you hundreds of thousands of dollars. On Solana, it was literally $1,000.
This is the greatest Solana explanation of all time.
Solana does more transactions per day from applications alone than Ethereum and all the layer 2s combined. Without any changes to the Solana protocol, you can literally scale it to millions of TPS on modern day hardware.
If you have a friend that doesn't quite understand crypto, send this to him or her. They will thank you.
What's unique about Solana is that it doesn't have any layers, it doesn't do the separation, and it preserves this composability, which makes things cheaper and faster. We have a meme called "Only Possible on Solana." I think like what's very different about Solana is if you go to like a Solana conference versus an Ethereum one, there's very few talks about scalability on the Solana conference. Every founder that you meet is working on a consumer application, whether it's finance, they're looking for consumers to use their application. They're not thinking about how do I scale this, or whether it's like NFTs, they're looking for traders, for creators, for whatever. As hardware improves, it gets cheaper and cheaper to run the network. As we predicted, the cost of the hardware drops roughly every 2 years by 50%. I'm not surprised by that. I hope no one else is. But like we started Solana, it cost about $1,100 a server, then it went to $800, now it's $350 a month. I suspect by next year it might be under $200 a month per server. You see like announcements like Google Fiber is offering 20 gigabit networks up and down to the home. So like this idea that Solana only runs at a data centers, even that's going away because simply you're getting what people previously believed data center only speeds, you're getting those to the home. And this is just a relentless march of hardware. And this is really like kind of the whole point of the way we design the network is that I spent my career as a systems engineer. As soon as you build the software such that it gets faster with hardware improvements, you're done. You don't actually have to worry about that problem anymore. This is what I really mean about scaling. Like, we're done. Like, we don't actually need to worry about scaling. We worry about reliability and stuff like this, and those are all kind of optimizations that are happening. Once Firedancer's out and there's multiple clients, we don't have to do any more core engineering work. I think there's still improvements that you can do, but really, like, the network is done. Firedancer is what I'm excited about. It's even faster Solana. Solana's already fast, it's even faster than that. Why it's important that Firedancer exists is because Ethereum is, I think, the only smart contract platform with multiple implementations of the protocols live. So they have 4 clients. And Solana, I think, is soon to be the next one with more than one. So Firedancer is the second implementation of the Solana protocol. So if you're not an engineer, how I can describe why that's really, really important is the probability of 2 different teams implementing the exact same bug in 2 different implementations of the protocol is virtually 0. And that means that now we have redundancy, we don't have any single points of failure. That's really, really critically important for decentralization. No single points of failure is awesome. I think this is like really the most important thing that decentralized permissionless networks provide is that reliability in terms of like real hardcore, like physical decentralization. Solana is kind of uniquely positioned in the industry to be non-sharded, no layer 2s, a single giant global state machine. There's a lot of benefit to that. The really cool thing that a single giant global state machine provides is composability. And that is that every application that exists in one single environment is kind of like running on a single computer, a world computer. So if you were to like, let's say, if I wanted to trade like 20 cents of dollars for however many euros that is, you can actually trade it across 5 different companies at the same time to get the cheapest possible price. And it would take like 1 millisecond to do that trade, like 1 second to settle it, and the cost would be like a fraction of a penny. And there's no way you can do that in the real world, right? There's no way you're gonna go to like 5 different foreign exchange desks and tell them, I'm trading 20 cents, give me your best price. And that's because the real world doesn't have that property of composability, right? Everything is in separate buckets and separate domains. And this is what happens when you have layer 2s and sharding and these other technologies, is that they separate the environment so you can no longer combine them. So this is the big advantage of Solana, and this is something that we think is really, really important for the benefits that crypto provides around the world. Because once you eliminate that friction between companies, between marketplaces, finance becomes cheaper, faster, like everything's better. And you can see that in like just the technical specs of the network. Solana does more transactions per day from applications alone than Ethereum and all the layer 2s combined. So like, I think they still have a lot of work to do to catch up on the technology front, both on price, performance, and like really everything else. What I hope to see is we see like a use case like Helium, which is a $5 data plan in Miami, go nationwide. And that means like we actually get to demonstrate to like, entire United States, look, here's like an entirely crypto-based project. It's building something that everyone can understand, like a wireless carrier. And it's doing it with crypto, it's doing it faster, it's delivering better data, and cheaper data to every cellular customer in the United States. My parents can understand that, right? Like, this is what I want to see succeed, and like I want to see more of those breakout use cases. So Helium using compressed NFTs to mint 1 million NFTs to represent their hotspots and connect that with the payments and services of the data rates coming out of their 5G cells. All that is happening on the same blockchain as USDC transfers that can pay for Helium data plans. So like all this stuff is happening in one world computer without any friction. The reason I talk about Helium so much is because it's like an example I can explain to like my parents, a congressperson, like somebody that knows nothing about crypto. You can tell them cheaper cellular service and like sign me up. This is a technology that was shipped with a collaboration between Solana Labs, Metaplex, and Helios, and a bunch of other folks in the ecosystem. Like all the wallets had to support it. So it's kind of a huge effort driven, I think, by John Wong from the Solana Foundation. And what compressed NFTs implement, the technical term is stateless accumulators. So you don't actually have to store the NFT metadata on chain. You just store the root of the Merkle tree. And it's super cheap. Because of that, we've seen costs for NFTs drop by like a factor of 10,000. So like there's a company that spun up out of this called Drip House that have invented a whole new business model. Instead of selling NFTs, they actually sell a subscription to users who sign up, and they get NFTs from the creators that they follow. And they have minted 50 million NFTs, I think at the cost of $1,000. So this is impossible to do on Ethereum, really impossible to do even on layer 2s. If you really mint 50 million NFTs on any L2 right now, it's going to cost you hundreds of thousands of dollars. Solana was literally $1,000. This means that like the cost of digital assets, like truly decentralized digital assets, has dropped to the point where it's as cheap as like AWS database entries. So you can now then give them out for free. You can build whole new business models to try to attract users. That's exciting to see. There's a bunch of companies trying to do this to onboard. This is something that like has been in the makings for a while. And I think in the Ethereum ecosystem, it's called account abstraction. But this is a native feature that's been part of Solana, like the virtual machine, from day one. And Fuse is built by a really amazing team, Squads Protocol, that have built a formally verified multi-sig. And that multi-sig can now basically act as a wallet. And the wallet is implemented as a smart contract on Solana itself. And that's really, really cool because it allows more flexible features and protocols to be added in the wallet that's running on chain. And some of the interesting properties of this multisig is that you can set up a wallet without any seed phrases by using multiple devices. Because you have multiple devices, you have redundancy. In case you lose one device, you can re-enable it. So you're starting to see a shift in crypto with these new technologies to get away from the old school, here's a piece of paper, write down your seed phrase and store it in your sock drawer. So we're like finally at the stages of like user experiences and like technologies to kind of make those weird UX problems go away. Like that I would have, I still can't explain to my parents how to set up a ledger or something like that. I would say the smart wallet technology, my parents are not going to understand. What they will understand is that you can set up two devices, right? Their computer and their phone, and maybe an iCloud account to now you work as a multi-sig that controls their wallet. Without any changes to the Solana protocol, you can literally scale it to millions of TPS on modern day hardware, We're not even talking about custom hardware or anything like that. These are like CPUs that anyone can buy on Amazon and like set up a machine and a servers and ready to go. What that's telling me is that we're basically already kind of have the technology to put all of finance on decentralized rails. So it's going to happen. It's inevitable, right? Like it's done, right? In terms of like technology, we've actually provably solved all the bottlenecks. Now it's just about adoption, finding those use cases, finding real world problems that this solves and fixing them and, product market fit, catching lightning in a bottle.